Hello everybody, thank you for joining me today. My name is Manim and today we're going to be looking at static electricity. So some of our learning objectives include to understand the processes involved in generating static electricity and to recall that only negative charges can move. So if you're ready, let's get right into it. Alright, so now let's have a look at what static electricity actually is. Let's have a definition for static electricity. Static electricity can be defined as simply the build-up of charge on the surface of a material. That's really all static electricity actually is. Now, there is something that you have to notice about this. Insulating materials are far better than conducting materials to generate static electricity. Now, why is this? Well, this is because a conducting material allows for the flow of electrons. So if you were to place some electrons on the surface of a conducting material, it would just conduct right through it, right? It wouldn't really stay on the surface. But an insulating material doesn't allow for the flow of electrons. Therefore, if electrons are on the surface, they stay on the surface. Okay, so that's something that you have to be worried about. Now, let's have a look at the diagram of a cloth, a perspex rod or an acetate rod, like that's the example we usually get in school, being rubbed by a cloth. Now, when a dry cloth is rubbed onto a rod, the electrons from the rod are scraped off and dumped onto the cloth. Okay, so electrons are gained by the cloth, and that's what makes the cloth negatively charged. Now, here's the really key point: the rod becomes positive from losing electrons. It does not gain positive charge, right? No, there's no such thing as positive charge moving. In fact, let me do that in big letters. No such thing as positive charge moves. The positive charge is contained within the nucleus of an atom. If we split the nucleus of an atom, we're going to have a very bad day because that's how nukes work. Here, all that's happening is that the perspex rod is becoming positively charged due to losing electrons. That's a very key point you need to remember. Now let's have a look at how potential difference develops in static electricity. Now let's have a look at static discharge, more commonly just known as sparks. So say I have my cloth, right? And I'm continuously rubbing on the rod, okay? So more and more a static electricity is forming, right? More and more charge is forming, being deposited onto the surface of my cloth. So static charge builds. Okay, now say I have my hand over here. 1, 2, 3, 4, 5. I know that's a bit deformed, but oh well. Let's label it just hand. Once the size of the charge on the cloth becomes high enough, a potential difference develops between me and the my hand and the cloth. The potential difference. Okay, now eventually when the charge is great enough, electrons can actually jump across this gap to my hand, right? And that discharge of electrons, static discharge, is what we call a spark. So electrons can jump across the potential difference to my hand and then into the earth. Because remember, the earth is at 0 volts, so whenever you have a potential difference, you always go from a high voltage to the lowest voltage being the earth. So the electrons will jump from the cloth to my hand and then into the earth through my feet. Okay, so that's what a static discharge is. Now you understand that a spark is nothing but the very sudden movement of electrons across a gap.